In the decades following the Apollo moon landings, space exploration did not stall. Instead of pushing further outward, agencies initiated a 50-year strategic pause, confined to low Earth orbit, to learn how to keep humans alive in the vacuum of space for extended periods. From an altitude of roughly 400 kilometers aboard the International Space Station, our planet is so massive it consumes your entire field of view. You cannot see Earth as a complete sphere from this tight orbit. It presents simply as a sprawling landscape of oceans, clouds, and continents. That 50-year confinement ended when the Space Launch System propelled the 4 astronauts of the Artemis II mission out of Earth's gravity well, successfully breaking out of low Earth orbit. The crew was never meant to land on the surface. They piloted their Orion capsule on a 10-day trajectory around the far side of the moon to stress test the hardware required for deep space survival. During this journey, the crew captured the highest fidelity visual record of deep space ever recorded by human hands. To understand the engineering that safely returned these astronauts, we have to examine the specific environmental realities and optical distortions captured within this visual record. Once a spacecraft accelerates away from the planet, that tight orbital perspective vanishes. The sprawling landscape shrinks, and the Earth finally becomes a self-contained marble floating in the blackness. On the outward leg, the crew captured a long-exposure photograph of Earth's night side. Even with the sun entirely blocked on the opposite hemisphere, the weather systems over the dark ocean are visibly illuminated. That light is moonshine, sunlight reflecting off the massive mirror of the lunar surface and bouncing back onto Earth. If you look near the top edge of that same photograph, you will notice a distinct, faint band of glowing gas sitting roughly 90 kilometers above the surface. This is the sodium line. This faint band of vaporized meteor debris is vital to astronomers. Observatories fire powerful lasers directly up into this exact atmospheric layer to excite the sodium atoms, creating brightly glowing artificial stars. By tracking how the atmosphere blurs these artificial stars, computers physically deform telescope mirrors hundreds of times per second to cancel out the distortion entirely. As the capsule crossed the boundary to the lunar far side, the terrain in the photographs changed drastically. The smooth, dark lava flows we see from Earth disappear, replaced by an incredibly rugged landscape saturated with overlapping impact craters. In the completely black areas of space behind the moon in these images, you will notice tiny white dots that look like distant stars. They are actually dead camera pixels. Because the capsule is operating far outside Earth's protective magnetic field, high-energy cosmic rays constantly bombard the equipment, permanently destroying individual pixels on the digital sensor. These glowing dots are highly visible artifacts, proving the unshielded radiation environment that this new deep space hardware is successfully enduring. As the Orion capsule completed its far side flyby, the specific mathematics of its launch trajectory created a unique alignment. The spacecraft flew directly into the shadow of the moon, witnessing a total solar eclipse. A total solar eclipse viewed from the ground lasts only a few minutes, but from the vantage point of the astronauts, the massive bulk of the moon was physically dominating their window. Because of that extreme proximity, it took the sun nearly 54 minutes to cross completely behind the lunar disk. That extended period of darkness allowed the crew to capture a surreal image. With the sun's glare blocked, the cameras picked up the dark lunar craters lit entirely by Earthshine, framed by the glowing plasma of the solar corona and a dense star field. If you look closely at the background, you can see a distinct diagonal line of bright dots. Those are Saturn, Mars, and Venus. That line physically maps out the ecliptic plane, the flat disk of the solar system where the major planets orbit. The most widely shared photographs from the mission show a different perspective. They capture a vibrant blue and white globe slipping quietly behind the stark gray lunar horizon, a sequence officially labeled Earthset. The optical reality of this sequence is that the setting motion is a complete physical illusion. The moon is tidally locked to our planet, meaning the exact same hemisphere always faces us. If you stood on the lunar surface, the Earth would hang frozen in the black sky forever. The setting motion belongs entirely to the speeding orbital trajectory of the Orion spacecraft itself. There is a secondary illusion at play regarding scale. The crew used heavy telephoto lenses, which compress the massive physical distance separating the Earth, the spacecraft, and the moon. This results in a view where the planet appears massive relative to the craters in the foreground. Processing this visual data requires us to abandon our terrestrial expectations. Concepts like sunsets and horizons are dismantled entirely by the mechanics of deep space. Minutes after capturing the final sliver of Earth disappearing behind the rock, the spacecraft slew completely into the radio shadow of the Moon. The massive bulk of the lunar body physically blocked all signals to ground control, plunging the isolated crew into a tense 40-minute communication blackout. Eventually, they emerged and initiated a violent return. Plunging back into Earth's atmosphere at nearly 11 kilometers per second, NASA executed a lofted re-entry. This trajectory allowed the capsule to bleed off velocity safely while protecting the crew from extreme internal pressure spikes. Transitioning from hypersonic flight to a controlled descent, the 4 astronauts splashed down safely in the Pacific Ocean, concluding the 10-day mission exactly on schedule and returning terabytes of crucial engineering data. The crew's survival and this preserved visual record physically validate the Orion capsule's life support, navigation, and thermal protection systems under extreme mission conditions. The 50-year strategic pause provided the data needed to bridge the engineering gap between low Earth orbit and deep space. With the Artemis II hardware validated across a 1,000,000-kilometer journey, we are moving from testing theories toward the sustained infrastructure required to remain on the lunar surface.